Okay, so just quick show of hands. Who has heard of TypeScript? Okay, about a bit over half.
I'm raising my hand right now.
Thanks, Phil.
That was a virtual hand.
Virtual hand. All right, cool. So we've got about a 60-40 split. So the goal of this talk is to firstly introduce TypeScript and then ramp up pretty quickly to get to the point where we can start demonstrating an inversion of control pattern within TypeScript. All of the code that I'm going to show you is available at that address. You should be able to just access it publicly. If you can't, let me know.
You'll send this out afterwards?
Yeah, I'll send the slide deck out to everyone in the meeting, and I'll also include it in that repo. Okay, so what I want to do today is firstly introduce TypeScript. I want to talk about my journey with TypeScript and kind of ask some broader questions about why you might be interested in using it. We're going to go into a code demo, our first code demo, which will be some greeting functions, so kind of one step up from Hello World. And we'll refactor a JavaScript program and hopefully identify some errors with that JavaScript program and convert it into a TypeScript program. We're going to then introduce a version of control in the TypeScript style. To do that, though, we're going to have to cover a couple of JavaScript concepts which are a bit newer. So we'll go into those and then we'll head to inversion of control. And then we'll hopefully put together a Node.JS API using the inversion of control pattern that we've just talked about. And then at the end, I'll just briefly touch on some TypeScript concepts that are kind of beyond the scope of this presentation, but are worth being aware of. Okay, so good question to start with. What is TypeScript? So JavaScript with types is the long and the short of it. TypeScript is a transpiled language. Does anyone not know what transpiling is? Yep, Rob, awesome. So transcompilation is the act of converting source code to source code, basically speaking. So in the case of TypeScript, we're adding type annotations. Now, just about every JavaScript virtual machine doesn't understand types or type annotations. So when we use TypeScript, what we actually do is we write out our TypeScript source code, and then we use what's called a transpiler, and that produces JavaScript source code. And in the first example, we're going to see exactly how that works. The transpiler is fairly flexible, and you can target newer or older JavaScript virtual machines. I've got any within inverted quotes because there's some crazy JavaScript virtual machines out there that who knows what they're doing. TypeScript is a superset of JavaScript, so that means that every valid TypeScript program is also a valid JavaScript program. Every valid JavaScript program is a valid TypeScript program. It's important to note as well that with all of these abstractions we're about to talk about, TypeScript doesn't actually impose any other language semantics on top of what JavaScript is already doing. It gives you types, but that's it. And one of the things that I think the authors did a really good job on with TypeScript is giving you JavaScript with types, and that's it. So all of the semantics that you already know about JavaScript will hold true. Can everyone put their phones on silent, please? So it's a language by Microsoft. But open source. Lots of awesome integrations with React and Vue. A little bit out of scope. Maybe we'll do that in the future. And Angular 2 is actually written in TypeScript and has first-class support for TypeScript, which is really awesome. It's worth noting as well that if you want to use a JavaScript library, an existing JavaScript library with TypeScript, you don't actually need that library to be written in TypeScript. You can apply types to it later down the track. We'll touch on that briefly, but again, it's kind of out of scope for this. So my journey, joined MacGyver, and we started writing JavaScript apps, and the JavaScript apps started getting big. JavaScript is great because you can start with it really quickly, but it kind of gets to a point where it's harder to maintain for larger applications. I find my experience with JavaScript has been that I don't have as much confidence refactoring my application as I would with something like Java or C#. I also find myself writing more tests in JavaScript to test things I might not test within a strongly typed language.
What kinds of things, Stuart?
So for example, JavaScript makes no assertion on functionality. So you don't know for sure if the values being passed to a function you've defined will be set. So you could get a null, or you could get an undefined, or you could not even get a value passed. On top of that, you might actually not know if the value is a string, a number, or a Boolean. You just have no way of knowing. So when you've got that situation, the editor can't actually tell you whether or not you're passing in the correct data. All of that has to be done at runtime. And those error messages can be obtruse at times, especially when you've got a big hulking monolith of an app. So I've been on this for about 6 months now. I've written a React app, so I do some I volunteer for an open source project in my spare time, and I've written a React.js app. The URL is available there, open source code. And I've written a Node.js app for IAG. Again, URL there. That's an internal URL, obviously. So you can have a look at that code when you get a chance. Just anytime you guys want to shout out, please do that, because it makes the talk a lot easier for me. You too, Phil. So kind of one of the other questions that comes up in this conversation is like, why do I need types? And Rob, we kind of touched on that briefly. But I think it's a bit of an elephant in the room, like do types, WTF, JavaScript's dynamic. TypeScript gives you type checking at compile time, so the issue that Rob just highlighted. You also get static analysis of your code. So when you see your code tracking through different paths, TypeScript will do things like say, hey, by the way, you might not be returning something here. Do you mean to return it? You've actually indicated that you want to return something, but you're not doing it. It allows design by contract at a language level, which I think is a really fundamental advantage of TypeScript so far, in my opinion. When you're writing with JavaScript, you've really got two abstractions. Those are modules and files, modules and functions. Now, in a big, huge sprawling system where you might have hundreds and thousands of lines of code, that might not be enough. And if you want to design by contract, you have to bring in a separate library or something like that. Whereas TypeScript, it allows you to do all of that at a language level. And we'll see how to do that in the example. You've also got deterministic code completion. Some editors will code complete for you in JavaScript. Do not trust them. They are lying to you. There is no way for them to accurately complete. At the end, TypeScript can, because everything is typed, obviously. Just on a side note, one of the awesome things I loved about coming from C# from dynamic, because I went the other way. I started with life with dynamic languages, and then I went to statically typed languages. I loved pressing dot. I'd just type in namespaces and press dot and scroll through the list and sing. Okay, with that said, let's...
How do you test the TypeScript code?
That's a good question, man. I've got some test cases that we'll go through in the second demo. Okay, so let's exit out of here and write some TypeScript. Hi. Okay, that's huge. All right, so I'm going to back the size off a little bit. Say when? Too far?
Too far.
Too far? Okay, that's cool.
That's perfect.
Okay, great. Okay, so this is a JavaScript program. And what it does is it defines a few functions. And everything comes from this say hello function. So down here I'm calling say hello. I've got an object, which is myself, calls this function. And then based on the job of the person, it will call either greet programmer, greet DJ, or greet unknown. And then up here, we've got those three functions defined, which will do something different depending on the job. So notice this is a perfectly reasonable JavaScript program. Some of the more astute in the room might see a couple of issues, and let's see if we can pick those up refactor this program as a TypeScript program and pick up some of the errors. So I'm going to quit out of Visual Studio Code, and I'm going to go through a really complex process of converting this JavaScript program into a TypeScript program. Okay, we're done. Okay. So
is that it? Talk over?
Yeah, we're done. Mic drop, lunch. Okay, so I renamed the file extension, and already we're getting a whole lot of issues that we didn't see before in a JavaScript program. I haven't added a single type annotation yet.
So will that execute now?
No, you need to compile it first. So let's have a look at what that compiled version is. So I'm going to run a command line app, which is the TypeScript compiler, and I'm going to tell it to watch my application. So what this is going to do is it's going to do two things. It's going to barf at me and say I've got a lot of problems with my script, and then it's going to sit there in the command line waiting for me to make changes. When I do make changes, it'll recompile. Notice we've got an index.js. This is my transpiled JavaScript program. So the thing I really like about this is it's just JavaScript. It's pretty much exactly my program in JavaScript. Despite the fact that I've got a whole lot of errors in TypeScript, TypeScript will still output the JavaScript for me.
So we're in an ES6 world, how we transpile from ES6 to standard JavaScript.
Yep.
Where would that fit in this chain
Okay.
of TypeScript?
Good question. So that's where your TS config comes in. So I can change the compile target. So you want ES6. Nope. Nope. Yes. You want ES6, you just change the target to ES6, and TypeScript will include all of the
Will output ES6.
Will
and
output
then
ES6.
Then transpile ES6 to whatever.
It will work around you in just about any way
Okay,
you
so
care to
that's
work.
an extra transpiling step. Yeah,
Extra
cool.
transcompilation
Cool.
step. That's all it can be. You can use TypeScript to be your final transpile. You can do whatever you need to do. You can change the module output. You can get it to write source maps for you. Pretty much everything you would expect to do with a JavaScript transpiler like Babel, you can do here with TypeScript. Okay, so let's look at our program and let's see if we can start to fix up some of the issues that we've got. So I'm going to go here, person. This is saying cannot find name person. Does anyone care to guess why not? No parameters. Thank you, sir. So I'm going to put that there. Now person is complaining that I'm just using an any type. So any type is every JavaScript type. I can say type any, and that's basically saying I don't know what type this is, but we're using TypeScript, so let's define a type. Down here, I've got the object that I want to pass into my functions. Now I know that this object has a job, a first name, and a last name. So I want to define a type for this object. And the way you do that in TypeScript is you define an interface. So let's do that now.
Is interface a TypeScript reserve word?
Yes. It is a TypeScript reserve word. And when I go back to my JavaScript program, it just disappears.
Oh, wow.
So
Okay.
TypeScript will look at your interfaces, check your types, decide everything's fine, and then output valid JavaScript for you.
So it's all at compile time, nothing at runtime in terms of type checking.
Yeah, nothing at runtime.
Oh, that's a good distinction. Yeah, so it's all a compile.
Yeah, everything happens at compile time. You can still get runtime issues with your types if you're, say, calling a web service and you don't know what data's coming back.
Yeah.
But nothing before that.
Yeah, right.
So I'm going to define the attributes of my interface. So we've got job, first name, last name. Job type is a string.
Strong if you're from New Zealand.
Depending on what side of the creek you're from. First name and last name. Okay, awesome. We've defined our first type. It's an interface. So now what I can do here is I can use the iPerson and say, whenever I'm calling the greet programmer function, I want the type that's being passed to this function to be iPerson. And lo and behold, the property full name does not exist on the type iPerson. Now, if you've ever maintained a large-scale JavaScript application, this is freaking awesome to see that. Because when you're refactoring, there's no way you could ever know. All right, so let's go and change some of our other functions. iPerson. iPerson.
You can easily enhance the Java program.
There's always a couple of those guys. And we can
It'd
all...
only be 500 lines long in Java.
Yeah, exactly.
Oh, shots fired. Sorry, I'm a Java programmer. It's okay. I can make fun of language because I am Java.
That was Java 1, right?
Java 1. Oh!
Not Java 8.
Okay, so I've created my object. It's an object literal. It conforms to interface iPerson. Say hello is complaining at me now. Hey, it doesn't match the signature call of the target. That's because this wants a person, so I'll pass that in. Now it's happy with me. All right, let's go through person full name. We're going to need to conjoin first name and last name. So we might have to do a little bit of a refactor there. So I'm going to come back to that one. But these other problems I think we can change. Age, we don't have an age yet. So this function actually needs an age. So we can extend our interface here and add age number. Just an FYI, JavaScript only has one number type, which is a really good idea from a language design perspective. They just chose the wrong type. So here now it's saying, hey, string first name, string last name is not assignable to iPerson. The property age is missing. Thank you, TypeScript. Let me add that now.
Is that your real age?
That is my real age.
It's suspect.
Missed a good chance.
So we've got a role, doesn't exist on iPerson. Same here. Why not? Because it's actually job. Okay, cool. Why don't I change that? Well, let me just... Yep, that one. Cool. What's that? Can I what? Yes, you certainly can. You mean have a property of an interface which is another interface? Absolutely, yes. Okay, so now TypeScript is saying I can't assign a result because it's a constant or read-only. That's because we haven't actually defined it. So let's do that now. And we'll make this a type string. Cool. Okay. Type void is not assignable to type string. That's weird. Greet programmer. Greet DJ and greet unknown are fine. Ah, look what we've got here. That's weird. So let's change that to a string. Can anyone guess what that string?
The return
ST.
type.
Ian Berry, top of the class. So that's the return type of this function. So this is actually squiggling at me too. So it's saying I'm declaring this function as a string type, but I'm not actually returning a string. So let's do that now. Fix up our syntax. That bug will come back to, and all of a sudden our program is valid. And we know that at very least the properties on our person are true. Okay, great. That's awesome. So what about refactoring? That's one of the other really nice things about TypeScript, because we've still got this this full name issue. So what we're actually going to have to do here is we're going to have to refactor our code and append the first name and the last name, because I don't want to change my interface now. I've put it out there. People are designing against this interface, so I need to refactor my program. So what I want to do is I'm going to define a class now. And for the Java guys in the room, this is kind of old news. But for the JavaScript guys in the room, you should be loving it. Structor. And I'm going to pass in person data. And that's going to be of type. It's called being a hipster, man. Ugh, can't even type on my own demo. And let's assign this. So this is our constructor. Let's assign the person data to this person data. So we'll make it a private variable because private variables are good, right? I think I read that somewhere in Java. Okay, it's complaining at me that person data doesn't exist. Oh, private variables! Thank you, TypeScript.
So does it actually have private
The, yes, but
Only-
I mean, obviously, when it gets transpiled, it's just going to have something internal to like the function.
So it's like there.
Yeah, but it kind of depends on what ES level you have.
Yeah. Okay.
So it depends on the way. Okay, so that knows we're an I person. Awesome. Okay, so now what I want to do.
Looks very much like Java.
I'm trying not to say too much.
No, say it.
Now what I want to do is I want to create an instance of my class, and I'll call it Stewart I for Stewart instance, and it's going to be of type person, the class I just defined, and we're going to go new person, and we're going to, okay, doesn't match the signature call, so I'll pass in Stewart. Cool. Sorry. Let's just put that there. Okay, so say hello. I'm going to pass in Stewart I. That's complaining at me. So let's make the changes required here. So I'm going to change that to person, that to person, and that to person. Now, previously refactoring like this is really hard. But with TypeScript, I know exactly what I need to change. So we don't have job. So Java guys, you're going to love this. Get job. Just for you guys. Get job.
You meant that.
I totally meant that. So get job. Can anyone guess the next line? Cool. All right, that's happy. Age, same again.
Can I check for another point in HTTP?
No, they're just undefined at runtime. Let's do the same thing here. Age looks good. Okay. Get age. Cool. And we'll do the same thing here. Get job. Awesome. All right, the full name. Let's make this a function. And then, again, this is going to be pretty simple. Can Java do string interpolation?
Java.
Yeah.
You mean like a
Yeah,
template string?
I think the new version of Java 8 allows you to do this sort of string templating
Oh, okay, yeah.
in line, I think, from memory.
Yeah.
Format. Okay.
Okay. So there we go. And
Nice.
voila, done. So we've taken a JavaScript program. We've fixed up 5 or 6 errors. We've defined our data, which is a really nice thing to do. And we've also added some functionality in and refactored our programming, refactored our program at the same time. And I haven't even looked at a single compile error or a single runtime error yet. That's been able to be all achieved through the editor.
So what editor is this?
This is Visual Studio Code, which is
Is this Microsoft?
This is Microsoft's editor. This is what the TypeScript guys use. It's open source. It's awesome.
It's runs on a Mac, obviously.
Runs on a Mac, runs on Windows, runs on your fridge.
Is it free?
It is free. Free and open source, yeah.
Free is it free or free?
Free as in freeware. Yeah.
Okay.
Not free as in Visual Studio Community. You can download it without signing up.
Okay.
Yep. So that's it. That's demo 1. Questions? Comments?
I have one question. This is Phil. I noticed that it complained about the position of your interface and your class declaration. So does TypeScript support hoist? It doesn't look like it supports hoisting. Is that correct interpretation?
Phil, that is an awesome question. I don't know. my suspicion is it probably doesn't. But I can find out for you. Good question. I don't actually know the answer to that.
Well, I mean, I would think that it doesn't, just by the way that it acted about how you
Yeah.
declare variables.
Yeah, I think you're probably right there. It was kind of saying, no, you need to actually define this. But at the same time, I was calling a function before a definition. So maybe it does in certain instances and not in other instances. It's a really good question. I'll find out.
Okay, one more question on getJob and getAge. You didn't declare the return type, so I'm assuming it implied any. Is that correct?
It will imply any. No, sorry, that's a lie. It will imply a string because it knows you're returning age, which belongs to the person interface. But another very good catch. I probably should do this. Wait. Number.
Okay.
String. But yeah, very, very good point, Phil. Yeah, I didn't actually put these on, but
So we can infer.
so it can infer from the interface. Yeah. Okay. Cool. So let's save that
I
up.
just would like to say one more thing.
Sure.
The TypeScript config object is much more robust than Webpack.
Well, I guess, they're kind of doing two different things, but yeah, I agree. Don't worry about this. And on this config object, it will get generated for you. So don't worry about knowing all the fields and stuff. It'll just give you, when you run an init.
I've had to debug problems in Webpack, and believe me, TypeScript is a walk in the park when you have issues compared to Webpack.
Right.
So, yeah.
Okay, so I'm going to keep things moving just because I'm worried about time now. So greeting functions demo done. So what do we learn? We learned that TypeScript has a compiler or a transpiler. TypeScript supports a pre-existing JavaScript type. So you saw me using number, string. These are just JavaScript types that you're already working with. You just might not know it. TypeScript defines the shape of data with interfaces. It's not a hard, fast rule, but it will make sure that I'm setting properties correctly. Functions have types and unions. I didn't actually get to demo this, and I will in the next part, so let's just skip over that point. TypeScript can transpile down to any kind of JavaScript you need. That's really significant when you need to target legacy systems. You can totally do that. And TypeScript supports a mix of interfaces and classes, and we just saw that with the interface of person and the class of person. Okay, so with that out of the way, let's move on to inversion of control, because that's the sweet cherry here. So I came across inversion of control about 6 months ago. I'd never heard of it. I got a background in Ruby, and I just loved it. I thought the concept was awesome, and at the time I was kind of battling with that sprawling system. So when I found out I can use it in a JavaScript world, I was really interested. And I've actually delivered a IAG service with using this inversion of control system, and I think it was a really awesome experience. Inversify itself is based on Ninject and Spring. Probably takes influence from both of them. Again, you're defining interfaces. You define implementations based on interfaces. And then you compose your container from the implementations, and then you can call your container from boundary code, which I think Spring does a little bit differently. I think Spring kind of gives you a lot of bootstrappy stuff that brings your container up for you. In TypeScript, it's a little more loosey-goosey, but we'll see how that works. Just a curiosity, who has worked with inversion of control here? Okay, cool. So let's just rip right through this. So we're going to be looking at a couple of new-ish JavaScript concepts. Firstly, we're going to be looking at symbols. Who knows what a symbol is? Tomo?
Is that something you played in primary school?
Yeah, so symbols are a type that are unique to themselves. So they can be represented by a string, sort of. But if you had a symbol that was like of the string hello, and you had another symbol of the string hello, they're completely different. The strict equality won't work against them.
Yeah.
So it's a unique value.
Yeah, exactly. And so the way the JavaScript virtual machine manages this is it has an internal symbol table. So whenever you create a new symbol, it holds that symbol in the table. So it's really good for using lookups and
Symbol, you mean variable?
yes, a variable of type symbol. So you call the symbol function that returns your variable of type symbol, and two references pointing to the same variable in JavaScript will always evaluate to true. If I was to create a symbol of Stewart and then another symbol of Stewart and compare those, they would be false because they're different symbols in the symbol table. So a symbol is a one-of-a-kind, once-off variable that is referred to in a global reference table within a given JavaScript virtual machine.
Always global?
Its scope is not global. The fact that it is a symbol known to the system is. So it's scoped to wherever you create it, but the fact that it's a unique symbol within the current running JavaScript virtual machine is unique. So when you compare that symbol to another symbol or to another reference, you know for a fact that you will always be comparing with that exact symbol that you've created, which is really important when you get into IOC land because IOC needs to do things like look up types for you. The other thing we're getting into is decorators. Now for the Java guys, it's pretty much what you know about decorators. As I understand it, my understanding of Java decorators isn't great. Essentially in JavaScript land, decorators give us an ability. When we define a class in JavaScript, the only properties on that class are function literals. Decorators kind of reintroduce this ability to manipulate those function literals from within a class definition. JavaScript developers have been doing this for years, just within an object. So the decorator spec is built in to solve that problem. But essentially, it gives you the same programming experience that you would expect to get in Java. Okay, so let's start the demo. I'm going to end show. Let's see. Okay. Cool. All right, so we've got a few red squigglies, but that's nothing we can't overcome. This is the boundary class, the boundary code that I was talking about. So what we've got defined here is the world's worst web server. We're using the Node built-in HTTP library to expose a web server. We're calling create server, and with the world's worst web server, you have the world's worst router. Literally does an if on request URL, and if it matches quotes, it will then call this controller object that doesn't exist yet, and the controller object is expected to return an interface that conforms to iController response, which also doesn't exist. So the way I approach this problem is I'll want to define the interfaces that I'm going to be using first. So let's do that really quickly. So let's define the iController response interface. And so we've got result here. So it's expecting a status code and a response. So I'm going to put status code, and that is a number because this is our HTTP status code. And I'm going to put response, which for now can be a string. Okay, cool. First interface done, easy. So we've also got this controller object, and what I want to do is I want to define my inversion of control container, and then I want to extract the controller out of it and feed it into this boundary code. So the first thing I'm going to do is define my controller interface. So I'm going to go interface, iController, controller. And this interface should enforce a find all function. So I mentioned that we've got the JavaScript types, number, string, boolean, all of those. We can also define types that are type functions. And a type function's type is unique to its arity and return value. So let's define that now and play around with it a little bit so we can increase our understanding. So I'm going to go find all, and then I'm going to use the following notation. and I'm going to say I control a response. So this is kind of in line with the question you were asking, Linus. Can I compose my types from other types? The answer is a resounding yes. So can anyone hazard a guess as to what this type is doing, or what I'm saying or expressing with line 11 of this program? Go for it, Tom. Go for it, Tom.
So it has to be a function that returns a controller response.
Perfect. Has to be a function that turns an iController response. Now, I can also define a function like this. That's perfectly valid to do as well. And if I try and implement a function within my controller class that doesn't accept 2 parameters, it'll blow up on me. So this is a unique type itself because of A being a string, B being a string, and the response, iController response. Find all and find some have the exact same type here. Find all and find some have different types now. Okay, cool. So, got my find all, got this mythological controller object. I'm just going to go back to the slide deck for a second because we've got some requirements here. It should return JSON, should return a list of quotes, and it should store quotes in a database. So we need some sort of database interface. So let's define that now. Database, find all quotes. That. And then I would expect this interface, I would expect this function to return a list of quotes. So that's what I'm going to do. QOTE. This is how we express arrays in TypeScript. So this is returning an array of quotes, which we don't have. Now we do. Cool. Okay, so I've got a controller, got a database. I might just change that back to that because otherwise it doesn't make any sense. We got our find all, we've got our database interface. All right, let's start making this concrete. I am going to firstly create the container. So to do that, I'm importing the container from Inversify. So this is our master IOC container. Const container, new container. Okay, cool. And we're going to bind our container. .bind. Now, bind is a templated method that accepts a type. In this case, I want to bind my controller. So I'm going to say types dot controller, iController. Types doesn't exist yet. And then we're going to say to our stub database class. Okay, so I've kind of created this the other way around, but I find it a lot easier to fix up red squigglies than to come to this at the end. So basically, let's make this line now work. So the first thing you're probably noticing is that we haven't got a variable called types. Let's create that now. So this is the variable that we're going to use for our type lookup, and this is what our inversion of control container is going to use when it resolves the types for us in the given classes. So let's create an object of types. And my first type is iController. And we're actually going to create a symbol, remember we talked about symbols, of iController. And while we're at it, let's add in our database for good measure. Our database, and the same thing here. So we're deterministic, and our inversion of control pattern is deterministic about what types we're grabbing. So supply parameters do not match this signature call of the target. This actually expects a types dot iController. So container bind. the interface that we've defined, the actual type that we're defining it to, and our concrete implementation. Probably not going to pass the database class to the controller though. So let's change that to our quote controller. Cool. So now it's saying I can't find quote controller. So let's define that. Class quote controller. And here I'm going to say implements. Now this is pretty traditional. Implements iController. Awesome. What's it complaining about now? Okay, it's saying we haven't got the find all. So let's do that. Let's define that. Net expects an I quote array, and we'll return our list of quotes. Nope, not like that. An array, and the quote object itself, if you remember up from the interface, has sum and should. So I'm going to set that to an arbitrary amount, and all of a sudden this is happy. Find all is incompatible type. My controller response. Right. So now it's complaining at me, and it's not saying. It's saying you're not returning the correct value. What I actually have neglected to do here is quotes. Quote. So if you remember from our controller response, it's expecting a status code and a response. So again, let's make it happy. Equals that. Oops. Nope, that was right. What am I doing? So we've got a list of quotes, and then we're going to return an object that actually aligns to that interface. iController response. Okay, so status code. We're going to say in our status code, we're going to say if we have quotes. If we have quotes greater than 0, let's return a 200. If not, let's return a 404. Is that the wrong way? Quotes length greater than 0. That's all right. And then response, it needs to be a string. So let's do a JSON dot stringify quotes. Cool. Now it's all happy. If I get my syntax right, there we go. Now it's all happy. So we've got our hard-coded list of quotes. We've got our interface. We've got our concrete implementation that should return a 200 or a 404. We've got the quote controller satisfied. So let's now fetch this out of the container. Get. We say iController. And here we say types.iController because we want to get it. And we'll assign this to a const iController. All right, so now we have our controller object, we have our components defined, we have our interfaces. Let's do the worst possible thing we can in a tech demo and try and run it. Okay, so I need to compile. Let me try that again. Okay, I'm gonna save this. So we have our compiled version of our program, and I'm now going to open a new window and going to run the program. Code. TypeScript IOC. I've actually set up a task to run the server, and that's erroring on me. Why is that erroring? Okay, so now it's complaining at me and saying, I don't know how to inject that class because you haven't annotated it correctly. So remember I talked about the decorators? That's what we actually need to do now. We need to tell Inversify that this class can be injected by adding the injectable annotation. Okay, that should have recompiled in the background, so I'm going to try and run it again. All right, cool. We've got our server listing on 3000. Let's see if we can call it localhost 3000/quotes. And woohoo, we've got JSON returning. Okay, but so what, right? Like, why couldn't I have just called that directly? We haven't actually injected any other requirements. So why don't we have a look at the database now? So I'm going to change my controller implementation, and instead of just having a hard-coded list of quotes, I'm going to say, I actually want to get it from my database. So I'm going to say this database. I'm going to go up to my database interface, and I'm going to learn that it wants find all quotes. Quotes, I quote, an array of I quotes. Okay, any guesses on why that's complaining? No database. I database. So we're going to define a private variable, so that's happy now. Find all quotes is part of the interface, but can anyone spot the problem? Anybody at all? Here's a hint. So in my constructor, I want to tell my ISC framework, hey, I want a database. I want the object that conforms to the interface database. So what I can do is I can use another decorator, and I can say inject. I use my list of my pre-coded list of symbols, and I say I want an I database. I want it to be called DB, and of course, it conforms to the type database. Why is that? Helps if the function has a body. So let's do that. DB, this database equals DB. Okay, cool. So we've now told TypeScript, we've now told the IOC that grab the database that you have. So in our case, we're going to have a stub database, because I don't really care about connecting to a whole big database at this point. So I'm going to say database here. Database. And then we're going to say, did I define a database? I don't think I did. Stub database that does nothing. So this is really good when you're starting out on a project and you just want to get something kind of working and you don't even want to make a database decision. Just paste that back. Okay, so let's find class. Implements I database. So what's it complaining about? Saying, hey, you need find all quotes. So let's just write that really quickly. Okay. My quote, return an array, and then in here we'll say sum ensured a different amount. Helps if I put the function definition correctly. I quote. Okay, cool. That's happy. That's happy. That's happy. Let's try and run it again. Almost forgot. we need to make the class injectable. Listening again. Where's my browser? And that's changed to the database. And if we were to change, thank you. And last thing, I promise, let's change our database so it doesn't return anything. We haven't changed any of the underlying behavior of the controller. We need to restart our server. Let's do a reload. Okay, it's empty. And our... Has it returned a 404? Yep, there we go. It's returned a 404 because the database has returned empty. So we've separated our database implementation. We've got a controller that understands what's coming back from the database, and we've got a flexible container that we can inject stub code in, and I wish I could have gotten to testing that. We got a flexible controller container that we can inject stub code into if we need, or we can test the individual components. So that's... I'll just rush through the rest of this because I stand. Yep, so we've done that. Allows IOC, symbols are great for unique IDs. Decorators add another abstraction that we're able to use. IOC definitely makes testing easier, and it forces you into a pattern of design by contract. We didn't get to a lot. These are some of the cooler sounding terms that TypeScript has. Further reading, I would recommend.
Well done.
Questions? I had that planned, man. We didn't get time. If everyone wants to stick around for 15 more minutes, I can do unit tests. But you've been watching me code for long enough, I would have thought.
What do you reckon the future of TypeScript is with things like WebAssembly and all that sort of stuff around the corner?
Good question.
Philosophical.
Yeah, it is quite philosophical. I think TypeScript is, so it's probably worth mentioning that TypeScript is one of 3 different technologies that are prominent in providing typed JavaScript. Which one of those wins out, I don't know. I'm generally going to back the horse backed by Microsoft. I think for bigger, larger systems, it will see more and more use. And the reason being is that I don't think JavaScript is I don't think Java is verbose because of types. I think Java is verbose because of their APIs and the API designs and the way they handle things like streams. So I would expect people like Rob to be running towards TypeScript and saying, "Wow, that's such a cleaner code, and this is what I've been searching for years."
It's interesting. I can see how JavaScript programmers are, because, as you say, trying to debug something, trying to refactor in JavaScript, you just get undefined and not a number, and
exactly.
left, right, and center. It's
Yeah.
very hard once it's a decent size.
That's exactly right. Yeah.
How much of the way that you wrote those was normally the way we do our code is a combination of restrictions of language,
Okay.
conventions of the programming community, like getters and setters, for example.
Yep.
Not mandatory, but we've got to put some in because Java means said you should do that.
Yep.
And our personal style.
Yep.
So how much of that was actually restriction of language? So say can you pass an interface in as an argument as opposed to a class? How much of
You can definitely pass a class in as an argument. That was a lot of the decisions I made with the programs I just wrote were made to demonstrate as many concepts as cohesively as possible. So as far as passing an interface in a class, like I might not do that on a day-to-day basis with TypeScript, but for demo purposes it kind of works because you get to see the two next to each other. So I think that's kind of where you're going with your point. Like I've got an interface of person that I'm passing into a class of person. From a Java perspective, that's kind of weird. And yeah,
from our perspective, that's kind of weird.
It is. I 100% acknowledge that. For a minute,
It's a builder pattern.
it's kind of. And do you know what? When I actually did the refactoring part, I did think about that. I'm like, yeah, this is not something that you would generally do and have like this data or whatever like that. It's weird. Yeah. But for the purposes of the demo and being able to refactor, I kind of just went with it because I felt that it sort of
From that perspective, it's
brought those two together. Yeah. Yeah, so no, probably, and you might not write your IOC container in one large file either with the app server. Like you don't. The reason I kept it in one file is again for demo purposes, but you'd probably have a class per file if you wanted to, or something else.
What are stack traces like? Are they error
Exactly the
messages?
same. The stack traces are exactly the same as in JavaScript
Yeah,
because they're JavaScript stack traces.
How about the error messages in like console or something like that? For using maps. Maps. Does that have that?
You mean source maps?
Sorry, yeah.
Oh, I mean it depends on how you're consuming them. So, .NET VS Code has line-by-line debugging that's set up with source maps, so you can step through and then you can see all your scopes, which is really valuable.
So you don't have to look at the actual compiler job.
Generally not. You don't actually, like you kind of saw there, I sort of left the compiler in the background and sort of hacked away in the editor. And that's one of the things I really love about this is the fact that I don't have to stare into the console abyss. I can see those red squigglies, a lot of those in there. Obviously, you're going to still get runtime errors, and they'll be exactly what you expect in JavaScript. But yeah, for the most part, I debug via, what is it, code by editor? That makes sense.
Sort of box you into a particular IDE?
I can only speak for VS Code, which has excellent support for TypeScript debugging, obviously. I know WebStorm offers debugging. Anything that understands source maps and can step through, that can pause a JavaScript virtual machine can debug TypeScript.
The only thing that I've seen is people commenting in their source maps, which is produced by a particular IDE. And
I know it, yeah.
Because you're using different IDE.
So TypeScript TypeScript transpiler will produce source maps for you. So just use those because they work in Visual Studio Code. And I would suggest any other TypeScript plugin for an editor should support the TypeScript built source maps. Big asterisk next to that statement.
Does it work for Vim?
Haven't tried it. Yeah, I'd look if you're looking to get started and you're not too opinionated about your editor. I'd recommend VS Code because it kind of works for you out of the box. I know they've got plugins for WebStorm, Vim. There's a plugin for Atom, Sublime, all the usual players. I think there might, if there's one for WebStorm, there'll be one for IntelliJ, obviously.
I think we're out of time.
Okay.
Thank you.
No worries. No worries, Phil.
Thank you, Phil.
Thank you.